Hi there, this is another video in which I'm going to solve a random Leetcode challenge for you. The reason I'm doing this is that I'm trying to spend some time learning how to solve those challenges, and I also need to make my YouTube channel more active. I'm trying to just combine two activities in one, solving challenges and providing you with nice videos. Hope you enjoy that. Hi folks, that's the second video where I'm solving different Leetcode challenges, and today we're going to have a little bit of fun with bitwise operations. So the challenge that we having today is called Hamming distance, and the Hamming distance is the distance between two integers. So essentially that the number of positions at which the corresponding bits are different. So we are given two integers and we need to return a Hamming distance between them. Check this out. We are given two examples. First is x equals 1 and y equals 4. So what's going on here? We have to change those numbers into the binary representation. For an example sake, they do it in a 4-bit style, but obviously the integer are going to be 32 bits in real life. So, and then they're comparing, like, for example, for 1, obviously it's going to be this, for 4 is going to be that. And the distance here is 2, because there are just 2 bits which are different. So far, so good. Let's go to the other example. Here it is. So x3, y1, and the difference is 1. The reason for that is if you convert 3 to binary, you will get something like this. It's going to be 0, 0, 1, and 1, which is different only by this bit from 1. So it looks simple. We're also given some constraints which are pretty much understandable. Those are constraints: minimum integer, which is 0 for unsigned integer, and maximum integer value, which is 2 power 31 minus 1. Again, nothing special about this. So let's see how we can solve this problem. To do this, we will need to use bitwise operation. And what we're going to do, we're going to essentially iterate through all the bits of our integers and compare them together, thus calculating results. So what we need to do, we need to have some placeholder for a result. So that's 0. And then we are going from 0 to 32. So for, I don't think we need index here. So for something in range 32, what we are doing is we are calculating bits. So first bit would be x divided by 2, actually getting a remainder of a division by 2. So if this is 0 or 1, right, and that gives us a bit, the last bit of the number. So that's the first bit, and the second bit is going to be pretty much the same, equals y divided by 2. Now we got those 2 bits. What we need to do is just essentially, if those are different, we increase the results. So what we are doing, if first bit is not the same as second bit, result increase. And then what we need to do, we need to use a shift right. So we are getting rid of the bit that we just created for both x and y. And then we return the result. Return result. Okay, let's see what we got here. Let's probably run custom test case. I believe that's going to be 1 and 4. That should return 2 if things are working right. Okay, so we got 2, which is promising. Let's try something bigger. I don't know. And this looks good enough to me. Okay, yeah, that's actually a little bit too much. Let's see. Yeah, okay, it looks like our solution is correct. So what we also could do is we could extract this to a function, just, I don't know, to make code a little bit cleaner. So let's say get last bit and number. So return number divide by 2. And now I believe code going to be a little bit more readable. Not everyone would agree with this. Some people would say that we are adding a penalty, time penalty, essentially, because what we are doing, we are calling a function, which obviously creates some overhead and eats some extra memory. But I don't think that's actually a big enough penalty to avoid readability. I think get last bit is definitely better than division, remainder of division by 2. At least it tells you what the code is supposed to be doing. We also, I think, can change this to something more fancy, like using XOR or something, but I don't really think it's going to be a good idea. I probably will add a little bit of formatting here. So that's our step, that's our loop, that's our result. Looks good to me. Let me run the code again. It's still passing, so I think if I submit, yeah, that's get accepted. So while that was fun task, a short one as well, I really hope that you enjoyed that. And well, yeah, see you around in next sessions.